Hey guys, it's Mr. Shilong here. This is going to be a video just in the case that either in class I wasn't able to get to explaining what to do in the analysis portion of this lab, or if you were absent on the day that you were able to work on this in class. Here's a video that's going to walk through what I'm expecting you guys to do. So, okay. So this is the soda can calorimetry lab. So on the first day, if you were part of group 2, you would have read all of this. And you would have gone through exactly, the point in which, or what the point is about doing this lab, all that good stuff. For group 1, you would have already began to burn things and to start the process as to, seeing that transfer of energy from one substance to another. In this case, it's going to be like energy from snack foods that's going to transfer over to the water and also the aluminum can, but also the water. At least for what we're mainly measuring here, that's going to transfer to the water aluminum can system in order to see just how much energy we lost from our food and see how accurate it is to the labels that they put, the nutrition labels they put on the sides of the boxes in cans of different foods. So anyway, so when you were working on this, so like for group 1, for instance, and this is going to be picking up, what group 1 would be doing today. You already burned a whole bunch of food. You measured the temperatures, initial and final temperatures of the water. You also found the initial mass and the final mass of both your food and holders. And now you're here at the analysis calculations, okay? Analysis and calculations, and this is what I'm going to show you guys what to do. So let's just say, just so I can have an actual example that we can look at, let's say that I'm only looking at the cheese puff here, okay? But I'll be only going through the cheese puff, but let's assume that I also have like the popcorn and the marshmallow. I'll only show the numbers for cheese puff. Well, let's say that for both the food and the holders, my cheese puff was roughly about 26.721 grams. And then let's say that my final mass after I was done burning the cheese puff, I measured this out, and I got roughly about 25.891 grams. Okay, so let's just say that's what I measured there, just as an example. And then let's say that during, when I was burning this, let's say my cheese puff, the original temp of the water was like, we'll say 25.4 degrees Celsius. And let's say that it went up to like 62.1 degrees Celsius. So, and we'll wait to do the change in temperature, the change in mass till the end. So let's just say that's what I got for my cheese puff. I can't do anything down here just yet, but we'll get to that in a bit. But these are the numbers I'll be working with here. My initial and my final for the mass, my initial and final for the temp. So it says here for number 1 to find the change in temperature in the water. So this is just easy peasy. The typical, delta T, the change in temperature is the final minus the initial temperature. And it says here, show your work below and this is for all of the calculations. So just to look at my cheese puff here, my final temperature for my cheese puff was 62. So I'm going to do this. I'm going to say, well, to find the change in the temperature, it's going to be 62.1 degrees Celsius minus the 25.4. Okay, and that's going to give me, wrong numbers. That's going to give me here 36.7, so 36.7 degrees Celsius. So this is the change in temperature that the water experienced in this problem. Okay, and I'll just write it here. Okay, this is for the cheese puff. This is what I'm writing over here. So cheese puff. And then I would, of course, after the cheese puff, then I would also do the cheese popcorn. And I'd do the same thing. And then down here I'd do the marshmallow, if those were my food items, food stuff. That's what I do. I'd do the same thing, showing the change in temperature for the cheese popcorn that I saw and the marshmallow that I saw. And I would record them over here accordingly in the data table. So that's how we get number 1. Okay, that's just finding the change in temperature. Number 2, calculate the heat gained by the water for each food item burned using the first equation. from the background section. That's basically just its Q is equal to M times CS times delta T. Okay, so it's just this guy. So if I were equation 1, it's just this guy. It is, again, it's Q is equal to mass times QS times delta T, so times the mass times the specific heat times the change in temperature. So here, this is calculating the enthalpy is what it's doing. We're calculating this right here. So let's just read a bit more through it. So then record these numbers in data table 3. Show your work below. Please show your work below. The mass of the water used is 50 grams. So every 1 milliliter of water is equal to 1 gram. Okay, and remember, this is sort of kind of like those problems we did in calorimetry number 3. Or these are more almost exactly like it, where we're having a change in energy from one substance that is being absorbed by another. So whatever the heat is that the water gained is the heat lost from the food stuff. In this case, it's going to be the cheese puff. Okay, so the mass of the water is 50 grams, and the specific heat of water, now this is new. Okay, we're measuring the specific heat a slightly different in this case right here. Okay, so if you notice, it's calories instead of joules. So what we just did is that by we I mean Mr. Hamer and I did the heavy lifting for you here and made the conversion for you to go straight from all of this stuff, from the mass and the specific heat and also the change in temperature, straight to calories. Because as you saw, what you should have seen here, that's what we need to have for the table 3. Because we're wanting to compare the nutrition label with how much energy was actually lost in this lab. Okay. So that's a whole lot of stuff. Let's just go through this. So let's see. These values are given to you, heat gained in calories. Show your work for the first one and then substitute the new delta T for each food. Yeah, and why do we do that? Well, because the water mass really didn't change. So what does this look like? It's going to look like this. So Q, we don't know. We're trying to solve for Q for all 3, for cheese puff, cheese popcorn, and marshmallow. So Q, we don't know. We know the specific heat of water is 1.0 small lowercase calories per every 1 gram by 1 degree Celsius. And remember, this is the heat gained by the water. And so what's the mass of the water? Well, it's about 50 grams. Okay. What was the change in temperature of the water, specifically just for the cheese puffs? Okay, in this case it was 36.7 degrees. Now again, this is going to change for all your other foods, so it'll be different for the cheese popcorn, it'll be different for the marshmallow, but it was 36.7 for the cheese puff. So I'm going to write in my equation. I'm going to plug in the correct values here, so 50.0, 1.0, and remember we don't use this guy for sig figs because that's an exact number, and 36.7, and I'm going to pop that in my calculator, and I'm going to get roughly about 1835, which really it would be 1840 lowercase calories. So 1,840 calories, roughly speaking, is how much energy the water gained from burning that, whatever that mass amount of cheese puff was. Okay, and again, then we do the same thing for the cheese popcorn. Okay, do that down here, do the same thing, only you substitute this guy out, and then you do the same thing for the marshmallow over here. Again, doing the same thing we did here, only swapping out the delta T, because the temperature, change in temperature will not be the same for these two. Okay, so okay, this is the change in enthalpy. So we figured this. Where do we put this? Put it right here. So the heat gain from a cheese puff, 1840 lowercase calories. Okay. Now we're going to move on to number 3, which is just converting lowercase calories to food calories, or kilocalories, which is uppercase C. And all we're going to do is we're going to divide the number we just wrote down, this 1840, we're going to divide that by 1,000. So for the cheese puff, showing my work, as it says, show your work below, for the cheese puff, 1840 lowercase calories to maybe 1,000, yeah, calories divided, and then you'd say like times 1 giant calorie. But anyway, we don't really need that. So divided by 1,000, and that's going to give us 1.84, because remember, this is 3 sig figs, that needs to be 3 sig figs, uppercase calories. So 1.84 uppercase C calories. Okay, so that's what we do for number 3. Number 4, for each food test, determine the change in mass for each food by subtracting the final mass of the food, blah, 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 and then we record this in data table 1. So going back up here, that's where we're going to do this. We're going to take the final mass minus the initial mass, or other way around, 26, because it needs to be, you know, it should be in this case, we'll keep it positive, the number, because it's already assumed that this is lost. So then it's going to be 0.830 grams. It's the change in our mass here. Okay, which all I did was this minus this. And then that's how I got that. Okay, so that's how much, relatively speaking, that is about how much of the cheese puff that we burned off. From that burning off, we're guessing that this is about how much energy, food energy, that was given off in the form of fire, that was transferred to the aluminum can, and also the water. Well, specifically, as we measured it to the water, I should say. That's how much we're assuming is measured to the water, not the aluminum can. Okay. So then you would do the same thing. You do the cheese popcorn, and then you would do the marshmallow. You do the same thing you did up here, showing your work, and then plotting that into your data table. And then number 4, for each food test, determine the change in the mass. Oh, we already did that. So that was like, so for the cheese puff, sorry, I didn't write out the work there. So for the cheese puff, that was, again, 26.721 grams minus the 25.891 grams that we got, which gave us 0.830 grams for the change in the mass of our cheese puff. And again, you would do the same thing for the cheese popcorn. And you would do the same thing for the marshmallow. Okay. Then number 5 comes along. So calculate the energy content per gram of food sample and record these into data table 3. And so you do this by dividing the heat gain in the water. So this is our answer from up here. So we're going to take this number and we're going to divide it by the change in the mass of food samples. So we're going to do this. So for cheese puff, we're going to say this. Well, we're saying that well, we need to know just how many calories went into how many uppercase calories were burned per gram from this cheese puff. So we're going to put 0.830 grams here. We're going to divide this by this. So 1.84, divided by 0.830, which is then going to give me 2.22. 2.22 uppercase calories per gram. So this is to say that for every 1 gram of this cheese puff, it gave off roughly about, or transferred roughly about 2.22 uppercase calories, 2.22 kilocalories worth of energy to the water. Okay, and so this number here is what we'll put into our data table right here. So that's where that 2.22 calories per gram goes. And of course, we're going to do the same thing for the cheese popcorn and also the marshmallow here as well, showing all of that lovely work. Make sure you do those as well. Number 6, then we're going to calculate the accepted energy. So this is the accepted amount. This is what we have. This is what we expected to see transfer. And where we get that is going to be from this little guy right here. So my cheese puff right here, okay, and this is from the nutrition label on the back of the bag. The nutrition label information says that one serving size is roughly about 28 grams worth of cheese puffs. And of those 28 grams of cheese puffs contain roughly about 160 calories, uppercase calories worth of energy in the food. So what we're going to do is we're going to find out how many calories per gram we expect to transfer given the nutrition label. So we're going to do this. We're going to say, well, for the cheese puff, we're going to say, well, it says here that there's 160 calories, uppercase calories, and that there are 28 grams in one serving. Okay, and we're going to divide this by this and see what we get. So 160 divided by 28 grams. So that tells me that roughly about 5.71 calories per gram. So it's to say that what's accepted is that for every 1 gram of cheese puff burned, we expect there to be about 5.71 uppercase calories, 5.71 kilocalories of energy transferred over to whatever new system. In this case, we expect 5.71 kilocalories to be transferred to the water for every 1 gram of Cheeto puff burned or lost. Okay. So, as you can probably see here, the numbers that I came up with are pretty far off. We came up with 2.22, but the nutrition label is it says like 5.71. And that number, by the way, we're going to put right here, 5.71 calories per gram. Okay, so we're kind of off here. We're going to see just how much we're off in number 7. But before number 7, just remember, show the work for your other food. Okay, just cheese popcorn. Just make sure you show that work as well. And then we're going to calculate the percent error. We're going to see just how off we are from the accepted value. And to do this, remember, we're going to use this equation right here. Measured value minus the accepted value over the accepted value times 100. So in the case for the cheese puff, we're going to say, well, here's what we measured. Okay, well, we measured roughly about 2.22, and this is an absolute value, by the way. So 2.22 minus the 5.71 calories per gram over the accepted value, which is 5.71 calories per gram. And you pop that in, and then you multiply that by 100 to see just how far off we are. Remember, when it comes to percent error, the closer we are to 0, the less error we have. The closer we get to, the higher we get away from 0, the increase in the perceived error in our calculations, in our experimentation scene. So it'll be 2.22 minus 5.71, which will give me a negative number, but we don't really care about the negative. It's really just 3.49 divided by 5.71 times 100. And roughly speaking, my percent error for cheese puffs is going to be 61.1%, which is a pretty freaking high number, man. That is a pretty super duper off answer. Okay. I thought I had other questions here. So maybe be thinking as to why it is this is so high. Why was our error so far off? There's a number of reasons why our numbers are so, why it's so wrong. Though what we did was pretty spot on as to how we could actually figure out the amount of heat transferred. But there are a couple of things that we did that would maybe skew our final measurements at the end. Try to think about all the different places where the energy may have transferred to a different form. may have been absorbed by a different system, may have been absorbed by a different thing. Okay, so I'll come back to that in just a second, just a reminder, also do the cheese popcorn and then, well, your other 2 food materials, remember to show your work here. So just as an example to kind of wrap this up now, this is a crude drawing of our system. So here's my ring stand, there's the base of it. Okay, here's the first, that's the first ring, this is the second ring. Here is my little wire, that's my little wire plate. And then here's my soda can. Okay, my lovely, lovely soda can. Whatever food stuff that we stuck on here. So whatever food stuff that we stuck on here to light on fire. Okay. Think about all the different places. Think about all the different places that heat could have gone to. Could have gone here, which could have gone in the air. Think about the fact that your tray here, your wire tray could have picked up, your wire tray could have picked up some heat. The actual ring itself may have picked up some heat. The biggest one that's probably the most, what would you say? The material I would say where most of that error is probably going to come from. It's that aluminum can. Okay. Now maybe think about why it is the aluminum can. Think about why that may be. Because yeah, we're definitely going to lose heat to the air. There's definitely going to be a wire, the wire tray is going to absorb a decent amount of that heat. And then the ring stand is also going to absorb a particular amount of heat as well. Okay. But maybe there's a reason why not all of that energy was able to get to the water, and maybe that aluminum can has to do with it. So if this is all to say that if you have a pretty high percent error, there's reasons for it. Okay, there are reasons for it, and there's other reasons I really didn't mention here that also could be explaining, what problems there are, and that could be, and some of those are just the way this is put together, this experiment's put together. But regardless, it's just to understand, this whole process is to understand how energy moves from one substance to another, and we can calculate just how much can transfer over by seeing what the temperature of water is and seeing what the change in that temperature of water is. So anyway, that is how you walk through these problems. That is how you complete your data tables here. And that is pretty much it for the lab, guys. So if you have any other questions for me, make sure that you ask. But if not, I'll see you in the next one.